Okay, number 23, we're multiplying these two things together, and realize that this is all multiplication, okay? There's no addition or subtraction here, so you would never use the distributive property in this situation. You would never go 3 times 5, 3 times square root of 8, square root of 2 times 5, square root of 2 times square root of 8. No, you don't distribute multiplication. If it's all multiplication, you don't use the distributive property. You only use the distributive property when you have something like 3 times a sum. Okay, that's 3a plus 3b. Or 4 times a difference. Okay, that's 4a minus 4b. But when you have all multiplication, no addition, no subtraction, no sums, no differences, you do not use the distributive property. You just put these numbers in a row and multiply them. Okay, so you've got 3, I'm just going to rearrange them. 3 times 5 times the square root of 2 times the square root of 8. Okay, so 3 times 5 is 15. Square root of 2 times square root of 8 is the same thing as the square root of 2 times 8. So 15 times the square root of 16. And you know the square root of 16 is 4. So 15 times 4 is 60. On 24, you do use the distributive property. You have a number multiplied by a sum. So you're going to multiply this times this plus this times this. So the square root of 3 times the square root of 27 is going to be the square root of 3 times 27, and I'm just going to write it the way it is. I'm not going to multiply it out yet. And then you've got square root of 3 times square root of 3, which is just 3. All right, the square root of 3 times square root of times 27 is the square root of 3 times 3 times 3 times 3, because remember 27 is 3 times 3 times 3. And then you've got this plus 3 still over here. All right, so the square root of, that's just 81, so the square root of that is 9, but if you just look at the two pairs, you'd have a 3 times 3 when you took it out, so it would be 9 plus 3 over here is 12. All right, here we want to solve for x in these equations that have an x squared in them. The way we do that is by first isolating the x squared. We have 9x squared equals 36. The first thing we're going to do is divide by 9 on both sides. The 9's cancel. We end up with x squared equals, 9 goes into 36 4 times. Now, if you think about it, the two solutions to this equation, there are two of them. Because 2 squared is 4. But also negative 2 squared is 4. So there are two solutions to this equation. And the way you solve an equation like this is you take the square root on both sides. Square root of x squared is just x. And the square root of 4, you would write the square root of 4, but you would put in front of it plus or minus. You put that little symbol to show that both plus square root of 4 and minus the square root of 4 will solve this equation. So anytime you take the square root on both sides of an equation, you're allowed to do it, but you have to put a plus or minus in front of the number on the right side. All right, so x in this situation is plus or minus 2. It's either positive 2, you could put that in and it works because 2 squared is 4 times 9 is 36. Or you could put in negative 2 because negative 2 squared is 4 times 9 is 36. So there are two solutions to that equation. But you wouldn't know it unless you remember that when you take the square root on both sides of an equation, you have to put that plus or minus sign. All right, same thing over here. You've got 8x squared equals 24. First you divide by 8. And the 8's are going to cancel and you end up with x squared equals 3. You take the square root on both sides, so x squared just becomes x, and you put plus or minus the square root of 3. So this would be your solution. Square root of 3 is an irrational number. You can estimate it to a decimal, but you can't write it any other way exactly as anything but the square root of 3, because it's a non-terminating, non-repeating decimal. All right, so just remember, if you take the square root on both sides of an equation, you definitely have to put this plus or minus sign in front.